we are going to get more into the quantitative information that we use in the lab, which means you're going to be able to calculate like how much stuff you should make when you combine this and this, or what your percent yield was. I should have made this amount, but how much did I actually make? Which are really important things when you think about industrial chemistry. When we're trying to create something, we want a high percent yield. How do we know if we're making the right amount or if there's a contaminant or something? And so that's kind of where we're going with this. How do you calculate the amount of stuff you need to make something or the amount of stuff that you're going to make? Okay, both important. So I want to look at this balanced chemical reaction. Okay, before we were balancing these with like N2 is a molecule, so I have an N2. I have 3 H2s, so 3 of these guys, which are H2s. I'm just drawing them kind of like as circles bonded, makes 2 NH3. So I've got this molecule and this molecule. So on the molecular level, I would say verbally that one nitrogen molecule, so one N2 molecule, reacts with, that means like plus, that's this guy here, 3 H2 molecules or 3 hydrogen molecules, that's this guy, to produce or to make, that's my arrow, 2 NH3 molecules or 2 ammonia molecules, that's this guy. So on a molecular level, it's one of these reacts with 3 of these to make 2 of these, okay? Now, since all substances, when we measure in moles, there's 6.02 times 10 to the 23rd molecules in each mole, we can scale these up to also be moles. So not only is this one molecule of this works with 3 molecules of this to make 2 molecules of this, but it is also 1 mole of this reacts with 3 moles of this to make 2 moles of this, which is more necessary for us in chemistry because we're usually not working with 1 molecule of this and 3 molecules of this to make 2 of this. We're using a lot of substance. We're going to weigh out a lot more. We're not using teeny tiny atoms and molecules. We're using bigger samples. So moles are going to allow us to actually do things in the lab because we can measure in grams and get to moles. So again, on the mole level, this equation means 1 mole of this reacts with 3, the coefficient moles of this to make 2 moles of this. Okay. Now, if I want to scale it up to the mass level, because right, we measure mass in the lab, not moles, because we can convert between mass and moles. Well, the mass of an N2 is 28 grams. The mass of an H2 is 2 times 6, so this would be 6 grams of H2, and 2 NH3s is 34 grams. So what this is saying is that I need 28 grams of this to react with 6 grams of this to make 34 grams of this. Okay, now using these numbers in the actual equation would be kind of confusing because it'd be like 28 and 6 makes 34, but that's not how the molecules work out. That's how the mass works out. So our balancing is always based on molecules and moles and not mass, but we do measure mass in the lab. So we have to be able to convert from mass to moles, and then we can use this equation. So those are the important things to remember when you are doing the math with these equations. So the first thing I want you to do is look at this equation again. This is the same equation we were just talking about, and say, if I had 24 molecules of N2, how much H2 would I need? Well, this is a 1:3 ratio, so I would need 3 times as many H2s, which is 72 molecules, which makes 2 NH3 molecules. So I would want to do 24 times 2 would make 48 molecules. And so on the molecular level, we can use these coefficients to figure out how many molecules I need. Okay, same thing if you want to try to fill in the rest of the table. This is molecules, and moles, which remember all go with these coefficients 1, 3, and 2. So go ahead and give that a try. Okay, and this one I gave you 150 molecules of H2. Well, I only need 1/3 of that of N2, so that's 50. So I need 50 of these and 150 of these to make, well, 2, right? So this is a 3:2 ratio. So what you can do to figure this one out is either, well, I already calculated I need 50 molecules of N2, this guy, right? And this is a 1:2 ratio. Every one of these makes 2 of these. So I just doubled this and got it to 100. Or you could have taken the 150 and then done times 2 divided by 3, whatever makes the most sense to you. But you might be looking at this like, man, these numbers just like they're hard to work in my head because they don't balance out. 50 of these and 150 of these makes 100 of these. And yes, that's how the molecules and the atoms work and how moles work. Mass-wise, it's different because of law of conservation of mass. So 50 of these and 150 of these, 50 of these and 150 of these make 100 molecules of this. And now I gave you a little bit more of an obscure number. I had 54. Okay, so if I wanted to make 54 of these, I need, well, half of that of nitrogen, so just 27 nitrogens. And well, I need, this is a 3:2 ratio, or you can look at this as a 1:3 ratio. I need 81 molecules of this to make 54. All of this is just ratios, ratios, ratios using these coefficients of 1, 3, and 2. Now our numbers are not always going to be pretty. And we, like I said, are going to be working on the mole level because we're going to use a lot more. So if I give you 0.57 moles of H2, well, I need a third of that for nitrogen. So I divide that by 3, I get 0.19 moles of nitrogen. And then this to this is double, so I double it to get this. So molecules and moles, you can use these coefficients to figure out like how much you need or how much you're going to make. Okay, so what you just did is called using mole ratios. These coefficients, again, give you the mole ratios. This is a 1:3 ratio. This is a 3:2 ratio, so on and so forth. So mole ratios are the ratio coefficients from the balanced equations. And just like any equality or ratio, you can flip it if you need to for your math in your dimensional analysis, which we are doing again. So there is a ratio of 1 mole of N2 to 3 moles of H2, or you can say 3 moles of H2 to 1 mole of N2, right? The ratios, you can flip them. Same thing, there's 1 mole of N2 to 2 moles of NH3, or 2 moles of NH3 to 1 mole of N2. So these mole ratios are why it's really important to have a balanced equation, because molecules react, or things react on the level of molecules and moles, not just looking at their masses.